So I'm here to talk about what's been going on with NVMe, the activities that we've engaged in over the last year or so. Oh, that's me. So we'll look at the state of the organization, the activities that we've engaged in, the different projects we've been working on, the latest versions of the specifications, and a highlight of some of the new features that are included in those new versions of the specifications. We'll also take a quick look at the roadmap of some of the things to come. So first, a look at the industry and what's going on with different SSDs. We start with the enterprise and the shipments of the different types of NVMe devices, different types of SSDs. You can see the largest group there being the NVMe ones, the dark blue ones. But there are also still some that ship using the SATA interface, using the SAS interface, or even some other types of interfaces. But the vast majority being the PCIe style NVMe devices. So you see there, just like with the enterprise, there's a little dip there. Things happened during COVID. There was some recovery time afterwards, that there was a little bit of slowdown, but things are ramping back up again. And so again, you see in this case, the two different channels for the shipments that go out either through OEMs or directly. So expecting a good continued ramp and a good continued large volume of NVMe devices shipping to the world. So just a quick look of where we were at the last FMS. A reminder, sort of set the baseline for what we've done in the last year, that when 2.1 released at the last FMS, we had produced 3 new specifications and we had updated the other 8 specifications. So all 11 of the specifications were provided at the last FMS, all announced and part of the 2.1 versions that came out in August of 24. So included in that were 71 different work items that we had been addressing during that time up to between 2.0 and 2.1. We had 82 of them that got ratified and included, and we even had 22 ECNs, corrections, clarifications, things to make it easier to use the standard. So that was where we were at a year ago. So we were really kind of overwhelmed at the time period between 2.0 and 2.1. There was just so many changes. There were so many new features. We were driving the release based on the availability of those features. And so the schedules weren't really highly predictable. When the marketing group said, oh yeah, we've got enough good features now, let's go ahead and create a release and we'll call it 2.1. Well, that was overwhelming. For the people to look at that, to look at all of those changes, to try and find the one little change that they were interested in was very hard. And so we have now switched to using a schedule-based model. So when the train leaves the station, whatever's ready gets on that train. I don't know if Amtrak is a good model to use and how their scheduling is. Maybe an airplane model, although they get delayed too. But we try very much to stick to a March and August schedule. So we're going to have a minor release that comes out in the March timeframe, and we'll be planning on every August here at FMS to tell you about the major release that just came out. And the features that are available, the features that are ready, completed, will be included in each of those releases. So the difference between the major and minor is that we're not planning any compliance test updates for the minor release in March. That is to help the developers, to help the people that need to be able to get access to all of the latest information. Now, what we do when we provide a new feature is we do make that individual feature available when that feature gets completed. So what we're doing with these releases in March and April is bringing them together all in one place so that you can get the combination of all of the new features that are available. So what we've had now happen between 2.1 and 2.3 which is between last FMS and this FMS, the 2 August releases. We've had 9 new work items come in that we're working on. We've had 8 either of those items completed or some of the previous ones that we were continuing to work on prior to that time. We've also had an additional 8 ECNs that have been released in the last year. So in the 2.2 release, the March release, we had updated 7 of the specifications to incorporate all of those engineering change descriptions, the new clarifications, things to make it easier for people to understand and to be able to implement the NVM specification. There were also some additional things that I'll talk about in just a minute. So in the release now, today in August here, at this FMS, we've released all 11 of the specifications as part of that August release, the base spec being called revision 2.3. So all 11 of them have been updated. So in the 2.2 release in March, you can see that there were 2 technical changes, 2 new features that were added. Those are the ones that were available for the March release. So these 2 were incorporated. We had some SGL support changes, and we had some descriptor enhancements for the EOM. The eye measurement. Thank you, Dan. Yep. We found that one of the fields that described the length of the data wasn't long enough for some of the data that needed to be supplied. So we had to extend the size of the field to account for the larger amounts of data. So in the 2.3 release, we have a number of new features that have been incorporated. So in the fabric area, the security area, several in the management area, and one which, while a technical change, is really considered a clarification for how that the capability was intended to operate, how the persistent memory region should have been described in the first place. But it is a technical change, so it counts as a new feature. So we'll look at each one of these. So in the fabric area, we know that path recovery is something that's very important to the NVMe EOF environment. You have redundant paths to be able to continue to guarantee access even in the face of failure. But the problem is that when you're detecting that path failure, each end of the wire can detect it differently because there's no, with the switches and such that are in between, there's no way for both ends of the wire to know at the exact same time what's going on. And of course, how do you communicate that? Well, if the wire's got a problem, the 2 ends of the wire can't talk to each other to coordinate and sort out how you're going to resolve that issue. So we created a protocol which allows the use of one of the alternate paths. So if you still have a working path, you can use that working path to communicate information about the path that has failed. And by being able to communicate that information, you can then have a more rapid recovery of that path failure. So a way to be able to do improvements in that redundancy area to get those failovers to happen much faster. In the security area, Sanitize has been, at this point, limited to the entire subsystem. To be able to sanitize the device, to erase the data, to destroy the data, to make sure that nobody else can get at that data anymore, you had to really destroy the device. And if you talk to some of the people that worry about government attacks, if you're worried about some foreign government accessing your data, even taking a sledgehammer to your device like we have in this picture here, that's not good enough. Those governments know how to take a platter like that and flatten it out, put it in their lab environment, and still get your data off it. So if you're really paranoid about destroying your data, then you've got to melt the thing or you've got to shred it into really, really tiny particles. Because even if you just cut it up, they can still take it into the lab, put the pieces back together again, and find a way to get your data off. Now, if you're just worried about your neighborhood hacker, most of them don't have any of that capability. That's only when you're worried about nation-state attacks. So what we've added is the ability to sanitize individual namespaces. Because we know large storage systems in multi-tenant environments have lots of different uses. So there's only pieces of data that you want to make go away. So the ability has now been added to the 2.3 specifications to erase, destroy, to sanitize all of the information on individual namespaces. And the intent of that is still to remain compliant with all the government regulations from NIST that are codified in the IEEE specifications. In the power management area, we have added some ability to further control some of the power capabilities. There were, in particular, some laptops that have cooling constraints where if you install certain devices, those devices could consume more power than the laptop was able to cool, which kind of presents a problem. People don't want their laptops melting out from under their fingertips. So we created a way to be able to have further controls on the power consumption of those kinds of devices. We're also working on power reporting. We have added one method of power reporting, and as you'll see in the roadmap, we're still working on some of the power reporting so that administrators, so that the systems that are using these devices can actually keep track of how green a device is by tracking the power. So a little bit of the future roadmap. You can see the green things that we've worked on that have come out through the last year or so, over 2024 and 2025, and working on things through 2026. So further security enhancements, the post-quantum realm. I think there's a session next door that's talking about that. We're working with CXL and making sure that NVMe can take advantage of the capabilities of CXL. Looking at Ultra Ethernet as a transport and seeing what is going to be different there than the traditional Ethernet. So migration capability, QoS, we'll talk a little bit more about QoS later in this session, as well as I mentioned, the sustainability stuff, the tracking of the power and other sustainability enhancements. So things to look forward to in the future of NVMe. So we continue to work on NVMe to add new features and capabilities. You know that NVMe is pretty ubiquitous. Laptops, large storage systems, arrays, even your cell phones. Most of them have some form of NVMe device within them. So it's quite a ubiquitous technology at this point. So since the 2.1 release a year ago, and the numbers I mentioned earlier, 9 new items to continue to work on over the coming year. We have completed 8 and ratified 8 ECNs. And just a reminder that the technical proposals, when they are completed, they do become immediately available so that anyone can incorporate those into any product that they're working on, and that we have our now twice-a-year release of the specifications to combine all of the things that have been released up until that point.